In the story of human flight, there are a few moments that cleanly divide the timeline into before and after. The Wright brothers at Kitty Hawk was one, landing on the moon was another. But squeezed right in between them, a rocket-powered plane and a single pilot achieved something many people thought was physically impossible. They were about to fly faster than the speed of sound. This is the story of that plane, a bright orange dart called the Bell X-1, and its incredible journey to break the sound barrier. During World War II, pilots started encountering a terrifying new enemy. It wasn't another plane. It was like an invisible wall in the sky that could tear an aircraft to pieces. As their fighters dove faster and faster, pilots reported violent shaking, controls that would freeze solid, and then a total loss of control as their planes were ripped apart by forces they just couldn't explain. They called it the sound barrier, and many believed it was unbreakable. But out in the remote California desert, a small team of engineers and one fearless pilot were about to challenge that limit. This is the story of their secret rocket plane and the man who would risk everything to fly it. So what was this demon in the air? The problem was a phenomenon called compressibility. Think of it like a snowplow. At a slow speed, it pushes snow aside with ease. But if it tries to go too fast, the snow piles up into a dense, solid wall the plow can't break through. As a plane neared the speed of sound, the air in front of it did the same thing. It couldn't get out of the way fast enough and compressed into powerful shock waves that hammered the wings and controls. For pilots in the 1940s, this was a violent and often fatal reality. Even the toughest planes of the era, like the P-38 Lightning, were no match for it. In a high-speed dive, they'd hit a point where the controls would lock up and the plane would plummet to the ground. This sound barrier wasn't just an engineering problem, it was a psychological one too. When the famed British test pilot Geoffrey de Havilland Jr. died after his experimental plane disintegrated, many in the aviation world started to think Mach 1, the speed of sound, was a limit humanity was never meant to cross. To conquer it, they needed a totally new kind of machine. The National Advisory Committee for Aeronautics, or NACA, the forerunner to NASA, knew a propeller plane just wasn't going to cut it. The project was top secret, named the X-1 for experimental supersonic. And in 1945, Bell Aircraft Corporation got the contract to build it. The engineers at Bell and NACA had a heck of a task ahead of them. How do you build a plane to survive forces that destroyed every aircraft that came before it? They found their inspiration in a pretty unlikely place, a .50 caliber machine gun bullet. Wind tunnel tests showed the bullet's shape was incredibly stable at supersonic speeds. So the team decided to design the X-1 to be, quite literally, a bullet with wings. The result was a machine that looked like nothing else. Painted a brilliant orange to make it easy to spot, it was just over 30 feet long with a 28-foot wingspan. It didn't have jet engines. Instead, it was powered by Reaction Motors XL-R1 one rocket engine, which burned a volatile mix of ethyl alcohol and liquid oxygen. This beast of an engine could produce 6,000 pounds of thrust, but it burned through its fuel in just a couple of minutes. To save every last drop of that fuel, the X-1 didn't take off from a runway. It was carried up to altitude in the bomb bay of a massive B-29 Superfortress and then dropped. Inside, the cockpit was tiny, crammed with over 500 pounds of instruments. And there was no ejection seat. If something went wrong, the pilot's only hope was to try and bail out. But the X-1's real secret weapon was something less obvious, its tail. On other planes, the flaps on the tail used for control, the elevators became useless in the shock waves, like trying to steer a canoe in a raging river with just a small paddle. The X-1 had a revolutionary solution, an all-moving horizontal stabilizer. The entire tailplane could be adjusted in flight, like angling the whole back of the canoe to steer. This gave the pilot crucial control right when they needed it most. This breakthrough turned out to be the key to supersonic flight. Now, a plane like this needed a very special kind of pilot. After some contract disputes, the job of flying the powered tests fell to the Army Air Forces. They needed someone with an intuitive feel for machines who could stay cool under pressure and who could push the plane to its limit and bring back the data. They found him in a 24-year-old captain from West Virginia named Charles E. Chuck Yeager. Yeager was a decorated ace from World War II. He didn't have an engineering degree, but he had what everyone called the right stuff, unshakable nerve, and an uncanny ability to understand what his plane was telling him. He was chosen not because he was a daredevil, but because he was a total pro known for his calm, methodical approach. Yeager quickly made the little rocket plane his own, nicknaming it Glamorous Glennis, after his wife. But as the historic flight approached, disaster struck. 2 nights before the mission, Yeager went horseback riding and collided with a gate in the dark, breaking 2 ribs. He knew if he reported the injury, he'd be grounded on the spot. So he only told his wife and his flight engineer, Jack Ridley. On the morning of October 14th, 1947, Yeager was in agony. He had to climb into the X-1 and lock the side hatch, a task made nearly impossible by his broken ribs. Ridley, ever the resourceful engineer, came up with a brilliantly simple, low-tech solution, a 9-inch piece of a broomstick handle. He could use it with his good arm to get the leverage he needed to seal the hatch. It was a makeshift fix for a flight that was about to make history. High above the Mojave Desert, the B-29 droned on. Taped up and in pain, Yeager squeezed into the cramped cockpit of the Glamorous Glennis. Using the broomstick handle, he locked the hatch. At 23,000 feet, the countdown began. Release. The X-1 dropped from the bomber like a stone. A moment of silence, and then Yeager fired the first of 4 rocket chambers. A massive kick of power slammed him back in his seat as the plane surged forward and up. He fired a second chamber, then a third. The Mach meter on his dashboard started climbing fast. Mach 0.8. Mach 0.9. As he approached Mach 0.94, the experience was like a boat plowing through its own rough wake. The plane started to shake violently. The demon was waking up. But Yeager, using that all-moving tail, kept the nose steady. He was in control. At 43,000 feet, he fired the 4th and final rocket chamber. The aircraft shot forward smoothly. On the instrument panel, the Mach meter needle quivered at Mach 0.965, and then it jumped. It flickered right past 1.0 and settled on Mach 1.06. He was flying at 700 miles per hour. There was no violent explosion. Instead, the shaking just stopped. The ride became incredibly smooth, as if the boat had finally climbed on top of its own wave and was now gliding effortlessly. Yeager had done it. He was flying faster than the speed of sound. On the ground below, observers heard it for the first time, a distant, thunderous double boom, the world's first man-made sonic boom. After just 20 seconds of supersonic flight, the fuel was gone, and Yeager glided the Glamorous Glennis down for a perfect landing on the dry lake bed. As he later put it, the real barrier wasn't in the sky, but in our knowledge and experience. While Yeager's Mach 1 flight became legendary, he wasn't the first or only pilot to brave the cockpit of the X-1. The initial test flights were conducted by Bell Aircraft's own pilots. A pilot named Chalmers, Slick Goodland, was the first to fly the X-1 under power in December 1946. He made 26 flights in total, pushing the plane ever closer to the sound barrier. But when the Army Air Forces took over the program, the flight tests were handed to military pilots, which is how Yeager got his chance. And October 14th was far from the end for the Glamorous Glennis. The X-1 program continued, flying a total of 78 times. The goal was to keep pushing the boundaries. Just a few months later, in March 1948, Yeager flew the same plane to a new record of Mach 1.45, nearly 1.5 times the speed of sound. At an altitude of over 71,000 feet, other pilots like Frank Kay, Everest Jr. would take the X-1 even higher, setting altitude records. These subsequent flights provided crucial data that couldn't be gathered from a single mission. The X-1 even performed the program's only ground takeoff in 1949, with Yeager rocketing to 23,000 feet in just 90 seconds. It was a program of continuous methodical discovery, not just a single daring act. The story of the Bell X-1 is a perfect example of what happens when brilliant engineering meets incredible courage. It laid the foundation for the entire jet age and the space age that followed. If you love stories about aviation pioneers, make sure you subscribe and hit that notification bell. And let us know in the comments, what other groundbreaking aircraft do you think we should cover next? The flight was so top secret that the public didn't hear about it for nearly 8 months. But its impact was immediate. The data from the X-1 proved supersonic flight was possible and, more importantly, controllable. This knowledge directly shaped the next generation of military jets, like the F-86 Sabre, which would go on to dominate the skies in the Korean War thanks to the lessons learned from the X-1. The X-1 was the first in a long line of X-planes that kept pushing the boundaries of flight, leading us right to the edge of space. Today, the original glamorous Glennis hangs in the Smithsonian's National Air and Space Museum, a silent tribute to the moment the sound barrier was shattered. It stands as a symbol of a pivotal achievement, proving that with ingenuity, courage, and sometimes even a piece of a broomstick, the biggest barriers are the ones we haven't tried to break yet.